Okay, hello students. So in last lecture we have discussed about the transport layer UDP protocol. Now we are going to start with the another layer, that is the application layer, and this is the last layer of OSI model. So when we discuss the OSI and TCP/IP model, application layer is the upper layer, topmost layer that interact with the user. In simple language we can say that act as interface between the user and your network and your computers, right? We normally we use the browser, the address we type, the protocol we use, that belongs to the application layer. We normally use the HTTP, hypertext transfer protocol. You all are aware about this. FTP, file transfer protocol. WWW, this World Wide Web. These all applications layer protocols belongs to the top layer. First we discuss the basic services that are provided by the application layer. So the first service, and the very simple and very old, these are the mail services, right? Everybody is using the basic structure of this. Everybody is using the email. I don't think there's no one that is going to be that not going to be use the email, that used to forward the message, that used to store the message. Then we have the network virtual terminal. Network virtual terminal, on simple language we can define this as remote login. Remote login means I'm sitting on this place and I'm able to use your PC. I'm able to access your PC, your folders, your data, able to perform all the functions on your PC. And this is something what we can call remote login, that it allows a user to log on to the remote host. There's the number of software that are going to support the remote login. Telnet, nowadays we are going to use this TeamViewer. These are the that creates a network virtual terminal. Network virtual terminal, that means created virtually with the help of network. Directory services means that provide the access for global information. Global information for the services, like the best example of this is DNS, domain name server. There are the various domains we will discuss in the further slides in detail. Then we have the file transfer, access and management, FTAM. Now this standard mechanism, first thing email, remote login, directory services, we will get the HTTP pages. Then we can transfer the data. I'm going to send the file, I'm going to upload the folder on somewhere. That means with the help of network we are going to transfer the files, right? That okay. Now first we will discuss the email. That is the most popular internet services, that is the email. Now that has the very simple architect. We'll discuss 3 or 4 cases for the email. We can define UA stands for your user agent. Let's say this is my system. I've already given a tutorial on how we can create mail server in the lab, right? How we can create the mail server, how we can use the DHCP server, how we can use the DNS server. Now let's say I have used the mail and this are on the same system with the 2 different username. Then we need only one user agent, right? That means only user agent for one. Alice and Bob, and both are working on the same. When sender and receiver of email are on the same, we need the 2 user agents. Sorry, not one, 2. One for Alice, one for Bob, but both are working on the same system. Now we have the second scenario. In that case, what will happen? We have MTA client. MTA stands for message transfer agent. Message transfer agent client and message transfer agent server, and they are connected through the internet, right? So obviously we have one user agent. What will happen in that case? When sender and receiver of an email on different system, we need 2 user agent and pair of MTA, client and server. MT means message transfer agent. Let's say one system mail server that is going to access the allies, one another server that is going to access by the web, right? And they are connected with the help of internet. Then we have the third scenario. What will happen in that case? That mail server is somewhere else, right? Mail server is somewhere else and you are connected to the mail server through the LAN, local area network, and then mail server connected to the internet, connected to the other mail server, connected to the another user through which you want to generate the data. We are able to understand this term. When sender is connected to mail server via LAN or WAN, and we need two user agent, two pair of MTA, client and server, right? This one, okay. So I think this is understandable. When one user is connected to mail server via LAN, and fourth scenario, user that is going to generate the email, user that is going to receive the mail, both are connected to the other mail server. So this is the practically scenario that we are going to assess. Let's say I'm going to use the Gmail and somebody is going to use the Yahoo or some Gmail. Normally they are connected through the internet and their account is stored on the mail server that is stored somewhere else. And if you understand, so what are the basic scenario? First, the sender user both are onto the same system. We need only two user agent, that's it, right? When sender and user are connected through the internet, right, but they are onto the server, then what we need the two user agent and pair of MTA, message transfer agent, client and server, one for client and one for server. Then third scenario, when sender is connected through the LAN to some mail server through internet that is connected to other mail server on which receiver is directly connected. In that case, we need two user agent and two pair of MTA, and this is the ideal scenario where both client and server is connected to the mail server through some LAN or WAN and the mail server are connected through the internet, right? Now this push versus pull email, push versus when client pushes the message, send and receive. In layman language we can say send and receive. When MTA client send the message to the MTA server, that we can count client pushes the message. When MA server sends the message to the client, that client pushes message, pulls, right? When both sender and receiver are connected to mail server via LAN or WAN, we need two user agent, two pair of MTA and two pair of MAA. I hope you understand this term. MTA, message transfer agent, MAA, message access agent, right? Okay, so this is how this mail works, and these are the simple services that are provided by the mail. Which kind of services that we are going to use into the daily life. These are the compose of message, reading the message, replying to the message. Then we have the forwarding of message and handling various inboxes, right? There are the mail driven user agent, mail, pine, AML, and we are going to use the Outlook. We normally installed it onto the our Windows, that Outlook that used to manage the various email accounts, right? Format, I think this is already clear that we have one header and other this. Now how we can define the email address? The first one is the local part and second one is the domain. Let's say I'm using rajan.csc@cu.in, right? The domain name cu.in, local is my Rajan, right? MTA client and MTA server. How client, this is the standard client server architect, client commands and server respond. MTA means message transfer agent, right? So this is your mail. I hope you understand this term, that we have the four basic scenario, which are the services provided by the mail and how this will work. Now we come to the another part, that is your DNS, right? Namespace means what? We are not going to Remember always the IP addresses or the server address. Let's say I want Google. Everybody knows www.google.com, but Google has some kind of server IP. We have already discussed in your lab tutorials when we ping the command to the Google, that shows some kind of IP address, right? So this IP is not able to understand. That is also another protocol that works on ARP, address resolution protocol. But on bigger end, we have the domain name server. That how you can define these various domain to the particular servers or to the various servers, right? Now to have a hierarchical namespace, a domain name was designated. A tree can only have 128 level, root to level 127. Let's say this is my root, ARPA, com, edu, org, add, zw. These are the various organizations. Normally these are the famous organizations. Com.com is used, edu for educational purpose, org is I think for non-profitable organization. So these are the various domain names, right? How this whole concentrate, how this whole organize, we have the root level, and this is the one diagram that will explain the all the scenario. That we have the one root is further divided into the various domains, .com, .edu, .org, and .edu is further divided into the subcategories, right? Let's say we have the root, then label is edu domain, then label fhda.edu, then we have atc.fhda.edu, challenger.atc.fda.edu. The more the number of levels, the more the number of level, higher is the range for these domain names, right? Okay, so this is how it works, right? So how this domain name works, that domain namespace is further divided into the subcategories, and the subcategories further divided into the subcategories, and so on, like in the subnetting that we have discussed. Like this is another example how this domains will work. Let's say on root we have one domain with the name of com, another with edu. So one yellow part becomes one domain, right? For yellow part there are the green part on left hand side. I'm discussing about the .com. On left hand side we have the green parts, and this green part, this one green also becomes one domain. Further it subdivided, this also becomes the domain. So here the root, further domain, further domain, further domain. This is how it works. This is how this will work. Like dot atc, then dot fhda, then dot edu. This is how it will works, right? So distribution of namespace, the information contained in the domain namespace must be stored. How it is very inefficient and also unreliable to have just one computer store. Obviously this whole information is not going to store onto the one computer. This is distributed among the number of servers, right? Now this is what hierarchy: root, arpa, edu, com, us server, .in. The number of domains are there, right? So you can also divide in favor of zone, that first .com is zone, then its domain, then zone and domain. This is some nomenclature that we are going to use, like for the country, district, and similar level. So primary server loads all information from disk file. The secondary server loads all information from primary server. When the secondary servers download information from primary, it is called zone transfer. Like first root will give information to the .com. .com will further give information to its subdomain, and so on. Hierarchy will works. Now DNS in internet. DNS is a protocol that can be used in different platforms. Domain namespace is divided into three different sections: generic domain, country domain, and inverse domain. DNS, that we are going to use generic, country, and inverse. So generic, country, and inverse. First, further it is going to divide. Country we have .in, .au, generic, .com. These all are the domains. Like this is the root level. This is the generic. We are discussing about the generic domains. Generic domain .arrow is for airspace industry, business, .com generally edu for educational purpose, for gov government purpose. So these are the various domain that can be used for the different purposes. These are the generic domain, right? Generic domain: arrow, airline, business, commercial, right? Educational, government institutions. So this is the one, this is only the same. Then we have the root level, then we have the country domain like FR, US, ZW, maybe for some other country, US for United States. This is how it will works. You all are aware about the .in is for the India. Now inverse domain, how it will works. Simply give the name, sorry, address 121.45.34.32 in address and ARPA. ARPA is, if we have already discussed, these are the spaces that we have already distributed from the root itself, right? So then resolution, this is the main important term, that mapping a name of an address or an address to a name, address, resolution. Mapping is always there, mapping a name to the address and address to a name. Now which address it is discussing, talk about, the address is IP address, obviously, right? Let's say we have www.google.com, google.com map to some address, and address map to the google.com. We have already done the practical regarding this same. We have installed the DNS server, then we have make an entry in DNS, we have make an entry of mail server and given the IP address. So this is how it works, like how this resolution will be done, right? So thank you. This is the first part of the application layer.